Okay, so good morning, good afternoon, or good night, depending where you are. It's very good to have you with us once more for an EuroStruct talk. This second talk we have an esteemed colleague, Professor Rafael Sachs, for sure the presentation will be very, very interesting for all of you, from students to our colleagues, professors, engineers, and so on. And I will only ask two things. You're gonna have your micro off, and I'm going to ask you, everybody, to turn off the camera, please. This is for a matter of Wi-Fi connection, and because we want to have the connection as stabilized as possible. So please turn off the camera. And another information that I want to share with you is that all questions that you want to make after the presentation, you need to do it, and all questions are very welcome, but you need to do it either on Facebook chat for those that are seeing us on the Facebook, or either on Zoom chat. So you need to write, it's very easy, you need to write in the chat your question, and we will put the question to Professor Rafael Sachs. On the Zoom chat, just another information, please put your question, if possible, to the account EuroStruct Association, so that we could concentrate all questions in the account EuroStruct Association, and then EuroStruct Association will send these questions to me and to my esteemed colleague that is sharing the moderation with me, the engineer Amir Kedar from Tel Aviv, from Kedmore Engineers, and he was also the chair or the coordinator of the working group 4 from Cost Action 1406 on case studies. For those that do not know Amir, I believe almost all of you know Amir, but it is also a pleasure to have Amir with me, and of course to have Professor Rafael Sachs, our esteemed invited speaker today. So I will now ask Amir to make the presentation of our speaker, and thank you very much to everybody from all parts of the world to be with here today for one more EuroStruct talk.
Hey, Jose, thank you. We are very honored to have you, Rafael, with us. Rafael is professor in the Faculty of Civil Engineering and Environmental Engineering in Technion, Israel, Institute of Technology, and now he's a visiting professor in the Center for Digital Build Britain in the Division of Civil Engineering, University of Cambridge. His research focused on the synergies of building information modeling, BIM, and lean construction. And we all know the recent work of you at the Seskin Virtual Construction Lab at the Technion, which he leads. He has included development of BIM-enabled lean production control system, a semantic enrichment of BIM models using machine learning and rule processing, with application to BIM interoperability, model acquisition from point cloud data, and code compliance checking. And also BIM system for earthquake research, rescue and recovery, and much more. We are also cooperated together in the Seabridge project, which Rafael was the leader of the project, which was very interesting and has some connection in many aspects to the COST EU 1406 work that was done by us. So Rafael, please, you can start.
Thank you very much, Amir, and thank you, Jose, for the invitation to talk this afternoon. It's a new experience meeting with everyone and talking through Zoom and through Facebook. So I hope that you can all hear me okay, and I'll do my best to make this as interesting as I can. Because the format is to begin with a 15-20-minute briefing and then open up to discussion and questions, I've decided to try to focus on some of the more principal issues behind digital twins, so less on the technology and more on the understanding of the principles that sit behind this. And although I do have a focus on the construction phase, I hope that the analysis will be relevant for operations and management as well. So to begin with, we all ask this question, what a digital twin is, and indeed there are a number of reports that have many definitions, but I like this one from the Center for Digital Great Britain with a recognition of my colleague Mark Enzer at the center, and it goes like this. We have some physical machine or tool or building or something in the real world, and we have a computer representation of that real asset. And then that we can visualize, we can see, we can test things. We then set up a data stream from the physical twin to the digital twin by using sensors of various kinds. They may be cameras, they may be video, they could be temperature, humidity, pressure, whatever sensors, occupation, and so forth. And then using that data within the digital twin, we can process that to generate new insights by simulating the performance, by carrying out engineering analyses of various kinds. And then based on what we can do, we can make decisions. So we can take decisions about how to manage that asset. And in the best case, we have some live way of intervening to operate that physical twin, to teleoperate it, if you like. And then, of course, there are some outcomes in the real world, and we can measure those. And we create a cycle. And that cycle is essentially what Deming called a plan, do, check, act cycle in the language of lean thinking. And then if we bring this to the world of infrastructure, the first thing we can do is we can understand that there is a distinction here, an axis, if you like, between the physical and the virtual. So we have the physical assets here on the left. We have the virtual assets here on the right, and they're represented by this kind of pixelated image of the real bridge. And fundamentally, we consider this on the right in the virtual world to be our digital twin. We monitor the real site, and then we use that to operate. And of course, the means by which we monitor it can be many different things. I've put up a list here of something taken from a recent research proposal we did, but they could be sensors of various kinds. It could be laser scanning of the physical state of that asset, photogrammetry, 360-degree images and other images, any kind of raster image. It could be barcodes, it could be radio frequency IDs or Bluetooth low energy, some kind of equipment, so a truck or a crane or other piece of plant might have a black box that's reporting on its own performance. There may actually be reporting by users through smart phones or other handheld equipment and devices. We could have back-end computer systems, ERP and others, providing information. And of course, we can have sonar or radio or audio recordings. And all of that goes into this acquired monitoring data. Now, if we consider this to be the first axis by which we can distinguish the physical and the virtual, I want to introduce a second axis, and I will introduce three altogether. But the second is this idea of ex post versus ex ante. What this means is that there is a state of the object, the physical object, when it is designed, in other words, before it's built. And that could also mean not only before it's built, but before it's maintained. And this, of course, carries on a timeline. So any given point in time could be our status point. Everything before the status point was the planning and the design. Everything after the status point is the actual performance. So what I can do here is I can distinguish and say we have in our virtual space, we have the BIM or the design model before the model is built. And so that exists in our ex-ante world before, and in our post world, our ex-post, we then actually build something or we control its construction and we end up with the real physical asset. And that doesn't have to be the initial construction. It could be an intervention to maintain that asset or any change in that asset that we want to generate. It can also be an operation. And then we monitor the asset and see what happened. And here's the interesting thing. I want to call this thing that we generate now, I want to call this the project status model, as opposed to the building information model. And what we can do with that project status model is we can compare it with our intent, which was in the BIM. Based on our comparison, we can make new decisions about designing and planning, which then creates a new BIM, which then creates our future actions in terms of either building or controlling our physical asset, which of course then we monitor. And naturally, we can also operate that asset from the project status model. So we distinguish between the BIM, the building model, and the PSM, the project status model. Do we call all of this together the digital twin? I believe that that's correct, because it incorporates both our plan and our monitored states, the ex post and the ex ante. We can also put something in this fourth cell here, in the physical world, but in the ex ante state, which would be a physical model. So that might be a plastic or cardboard model that we build from the BIM, which we use to evaluate, design, compare, and so on, to improve our design before we go ahead and build on site. So that physical model might represent a prototype. But in fact, what this BIM is giving us here is a prototype, a digital prototype, as opposed to that physical prototype. But they both belong to the ex-ante world. I'll leave that out for now because it's not central to our discussion of digital twins. So let's just have a look at this diagram and see that we actually have three kinds of information, and they're quite different. And here there is, I guess you could call a philosopher, Floridi, who wrote a book called The Philosophy of Information and defined a number of different kinds of information. I want to pick up on three. The first kind of information is physical or factual information. Now what that is the actual physical reality. So we have our asset or our site, which if it has dimensions, it has temperature, it has pressure, it has all sorts of properties that belong to that physical asset or that we can measure on that physical asset, and those represent physical information. The second kind is instructional information or information for reality. These are algorithms or commands or ways of dictating how we do things. For example, a recipe for cooking would fit in this type of information. And our BIM model fits this. Our BIM model expresses our intent of what we want to do in the real world. And finally, we have semantic information. And that's information about reality. It could be a map of, the geography of a place. It could be a timetable representing how the trains are running. And that, for us, at least, is the project status model. So it's a digital representation of the physical reality. We try to make that as real time as possible. So it represents the actual state, but oftentimes there is a lag between the measuring and the reporting and the interpretation, so that usually the PSM represents our site as it was at its last status date. So I said that there would be three axes, and so the final and third axis I want to introduce is this, is that we actually talk about product and process. So we tend to think of BIM models and this PSM as representing the physical object that we're dealing with, but in fact it's representing also the processes, the actions. And by that I mean the construction actions or the maintenance actions or the operations actions, including the resources that do them. So a tower crane, a concrete truck, a pump, scaffolding, a jackhammer might all be part of the construction process. They need to be modeled as well. Indeed, many of them may have their own digital twins. They have a digital twin for the construction tower crane, which would be no less valuable than the digital twin of the site as well, and they function together. But all of these things belong on the process side of this process product axis. So in the physical ex-post world, we have the building itself under construction, and we have construction or renovation processes underway. We actually, those both are controlled by the BIM as design, the model of the physical product, but also what I like to term the BIM of the plan, which includes the construction plan. That may be a CPM network, it may be a last planner system method, and so on, but it represents the design of the actions, our intent. And we monitor the physical world, but we also monitor what happened. We want to know how many hours people did something. We want to know how much fuel was consumed. in an earthworks operation and so forth. So we have these three distinct areas. And our digital twin, as I said before, we can consider to be all of this right-hand side virtual part of our world. Now let's look quickly at this life cycle of the digital twin, because I think here we get a good view of how these things play out over time. So we consider the start of conceptual design, prefabrication, construction, handover, and operation. The design, plan, construction, operation. And the first thing we begin designing, we create through a process of virtual design and construction, the design, detailing, planning before, and it runs through construction until the end. And here we have the as-designed product and the as-planned process. And in the real world, above the line, we begin perhaps with some off-site prefabrication. We then begin construction on-site. We have the building under construction and maybe also model the construction plant. This would be the tower cranes and so on that I spoke about before. But as that happens, we monitor all of that and we compile the project status model. So we have the as-built product and the as-performed process. And when we eventually hand over, the construction is finished, we have here the real building in operation, and we monitor it. So we also have an as-maintained renovated product. This is the digital twin of it. And we have the monitored data, which goes and accumulates over time. And then, of course, these parts, the as-performed process, the as-designed product, and the as-planned process, generally, they're not accumulated together with the monitoring data as life goes on, but they are shifted over to a project archive, which represented everything that happened during construction. And the information contained here in the as-maintained and renovated product is not exactly the same as the information we had here or here, because a lot of what we had here was no longer relevant for the operation. And what I find interesting, we of course can use then existing conditions, real physical conditions and virtual, to inform our future design. But if we think of this as in human, since we're using the metaphor of the twin, if we think of the conception, the birth, the weaning and maturity of the twin, we could do this. We could call this our physical twin child, building under construction. We then have an adult physical twin. We could call, as we monitor the physical twin child, we have a digital twin child during construction. And then we have an adult digital twin that sits opposite our adult physical twin. And that's the one we use for operations and maintenance. That leaves us to name this green design bit. The digital twin fetus is one option that people may like that or dislike it. I'm not that happy about it. If you have a better idea, I'd be very happy to hear. Based on all of that, we do have a design for a digital twin architecture for the construction phase. And I won't spend a lot of time describing this, but this really is the basis for our BIM to twin project, which is due to begin at the end of this year. But the basic idea is this, that we want to implement a Deming cycle of plan, do, check, act. And so in that sense, if I color these as plan, do, check, act, we first design and plan over here, using predictions of performance. We create the BIM. Based on the BIM, we build and control the construction. We generate the physical building twin. We then monitor it. This is part of the check now. We create raw data. We must interpret and merge that data because the raw data itself is not of any value. By interpreting and merging it, we create the as-built product and the as-performed process in the project status model. We can then draw direct comparisons between our intent and our outcomes. So we evaluate performance, that's still part of the check. And then we go back and act. And we take new decisions about how we should modify our design or modify our plan. And then the cycle continues until construction ends. I just want to focus here on this question of interpret and merge because I think it's a key thing. All of these monitoring technologies that I mentioned earlier, they can be registered, they need intelligent compression and so on, but they generate data. And that data is usually a huge stream of big data, which we must interpret and merge using complex event processing in order to create that project status model, which we can then compare with the BIM. And this part is a major challenge of using digital twins in the built environment. And so finally, one final aspect, and if I just pick up this digital twin thing, we recognize that one digital twin of one aspect of a project may interrelate with others. And so then we have a system of digital twins. And indeed, and again, this is from the Center for Digital Built Britain here at University of Cambridge, that system may interact with other systems, in this case, in the transport sector. But there could be others, of course, and there are others. And eventually we end up with a whole system of systems of digital twins. Eventually we might even consider a national digital twin where systems are talking and operating, interoperating in reality, not only in the digital world. So to sum up and do some conclusions, what are the highlights I'd like to leave you with? Well, digital twins are an information process. So we have an information challenge, and the key one there is this complex event processing to derive information from data. And the second challenge is the process challenge, a more difficult one. It's not technological. Our whole idea is to create shortened cycle times so that we can do this PDCA control. And the shorter our cycle times are, our assumption is the better we can build and design and construct, and the better we can operate and maintain our IC. I'll leave you with the thought that digital twins are systems of systems, that actually digital twins comprise both the BIM models and the project status models. And finally, that the twins model both the product and the process to finish the third axis. And I know I've gone over time, and I apologize for that, but I hope it's at least set the stage for an interesting discussion.
Thank you very much, Rafael. For sure, you focus a very relevant topic nowadays, also in not only in the construction industry, but I would say in the operation industry that is more than the construction. I will only ask everybody again to first to turn off the cameras for those that have the camera online, so please turn off in order to maintain the web stabilized. The second thing is that if you want to place any question during now this period, you should play the questions on the chat itself, and if possible you can send the questions to the EuroStruct Association account that is in the Zoom chat. For those that are seeing us in a Facebook, please put your question or comment on the Facebook, and we will share with Rafael those questions. So I will start now with the first question. I think is a little bit provocative. We have a lot of investment on operation of infrastructures. We also see a lot of investment on the research projects nowadays covering digital twins. What is needed to fulfill the gap? What are the required steps, in your opinion, in order to put in reality the digital twin in service to our esteemed operators for different type of infrastructures?
Okay, great question. And I think the answer depends on the level of functionality that you want to obtain from that digital twin. We see already, there are some commercial companies already with products on the market that allow you to build digital twins, for example, of bridges, tunnels, railways. I can think, for example, of two just offhand. First is a company called Locklab in Germany, who together with Deutsche Bahn are building digital twins of the railway systems, and they're doing it not using BIM, but using Unity and game engine software. So they are able to compile very rapidly and very effectively visual digital twins so that one can travel the tracks, the train line, virtually and inquire different things about that system. And you can also attach alphanumeric and other information onto that visual description. A similar company is one called Dynamic Infrastructure, a startup company who are doing a similar thing for bridges and tunnels. And again, it's very light in terms of modeling the product. Again, they only use visualizations that they obtain through videogrammetry and photographs. But then again, they allow you to attach alphanumeric and report information to those visual images. If we want to go further and we want to actually use those digital twins for more thorough planning, more thorough design, then we actually need to have BIM models of that infrastructure. Now, for infrastructure that's new, that we're building, the tools for going from BIM to the representations we need, the BIM representations that underlie the project status model, that's not too hard. If we're dealing with existing infrastructure, then we're looking at things like laser scanning, photogrammetry, and others. And indeed, my colleagues here at the University of Cambridge, Dr. Yanis Broullakis and others around the world are doing a lot of work to create a reality where you can actually scan physical assets and create digital assets, including BIM models. And Amir mentioned the Seabreak project earlier, where we tried to go all the way, the full gamut from scanning and photography and photogrammetry all the way to an intelligent BIM model. And that's still a challenge because to get a semantically rich model, we still need to do semantic enrichment, and that's not trivial at all. In terms of the instrumentation, here too, there are a lot of projects and a lot of products in the market. Again, the Langer Rock Center at the University of Cambridge have projects in monitoring bridges and monitoring other physical infrastructure. There are now even projects of satellite monitoring of infrastructure, and that's becoming very interesting because those are monitoring methods that are essentially free, for our purposes at least. So we need to develop better information systems, I would say, that tie everything together for anything but the most rudimentary visualization. And those will come when we research more in compiling models from scanning and other acquisition, when we manage to do the complex event processing in a good way so that we are able to monitor the processes, not only the products, and when we're able to do the semantic enrichment I mentioned before. So I hope that answers.
Thank you, Rafael. Now, I mean.
Okay, Rafael, I have another question, maybe from different perspective. We all know that the BIM process, the introduction of the BIM process to the design world and to the construction world was involving a complete change in the design process, actually. All the traditional way of designing is actually shifting to different phases, which are, we all know that they are different. Now, can you estimate what change of this type of system that you, of the digital twins, will do if the current traditional workflow all over the way from design to real structures and back, because we know that it might create maybe different professions or different things.
Yeah, no doubt. And of course, we have seen big changes in using BIM, but I think that the changes that we will see as we go into digital twins for the construction phase and for operations and maintenance may be even bigger. For one thing, we'll see systems that will become ever more autonomous. And so the availability of data and digital reflections of the real world slowly over time will let autonomy or autonomous machines creep in. So things like a tower crane that will now, instead of the operator actually having complete control of the tool, it may be that some of the lifts are done in a more remote way, that they signal the start and the end, and then some AI takes over in between to actually operate the machine between point A and point B. And after that, you can imagine that the operator might disappear from the tower crane, and so on. And when we reach a point where the tower crane and the truck delivering the material also are able to communicate one with the other, then you might see the whole scheduling of the lifting operations being operated or controlled manually, with people monitoring but not necessarily directing and directly involved. And I think that kind of change will be right throughout, both monitoring. You may see bridges with systems that are able to repair things automatically, or perhaps paint themselves in positions where the software and the AI is going to tell them to go and paint themselves, or do things of that kind. So it does open the door to increasing modes of automation, and then inevitably people's work will shift. There will be much more work in maintaining and operating the software systems than there may be in actually maintaining and operating the real systems. And I think that's true for across transportation systems, but buildings as well. And if you think of the now, I don't want to suggest for even a minute that that's going to happen within any kind of time frame. I think we know that Bible tells that prophecy is the province of fools. So I'm certainly not going to try to prophesy any kind of timeline, but it will happen step by step and slowly. And the last thing I'd say is that I think that a lot of these changes will come from startup companies who are able to take on the risk of trying out new and novel ideas at the risk of failure because they're venture capital, risks that construction companies and perhaps also infrastructure operators are not willing or not able to take on their own. And so we will see increasing innovation. Innovation may be then purchased by bigger companies, but I believe it will come from that kind of business structure.
Okay. Rafael, we have here one question concerning the use of digital twin and how this can impact on the construction costs. What is your opinion?
Okay. Here I want to go back to the first principles that we start from, and that is the questions of product and process. So I think that as long as we use the digital twin only for the product, and then really we're talking about the BIM model being a prototypical representation of the real building, then we can of course save money by improving the quality of our product, by using analyses, simulations, and so on to optimize our design. But when we think about the process, the construction process, the history of the last 20 to 30 years has shown us that we've developed, I think, a deeper understanding of how construction processes work. And that's largely thanks to the thinking of people like Costella and Ballard, who were able to particularly put the emphasis on flow, on the understanding of flow in construction, which means that we can look very closely at the waste. So we can see that when workers are waiting on site, or when they're doing rework, or when they're over-processing something, or they're doing work that's not necessary, or they're not doing the right work in the right sequence, then obviously we have waste, and we're using more resources than we need to. So the whole thrust of lean construction has been to try to change people's behaviors, change their management processes, change their planning activities to get rid of a lot of those wastes. And because the percentage or the proportion of waste is so large, it turns out that you can improve productivity not so much by using better hammers or better concrete pumps or whatever, but by just making the work that they do, that those people do, take more of their time on site than the wasted time that they spend walking around and waiting and so on. So now we ask, can the digital twin contribute to removing some of that waste? And in some ways, it may be the case that working through software and having software help us with optimizing processes and optimizing productivity through planning, we may be able to recoup more of that waste than we are by simply retraining supervisors, retraining foremen, retraining managers. And partly, if we want to have just-in-time deliveries, for example, we may be able to use the digital twin to send information to the delivery truck, which may in the future be autonomous, and to the tower crane, and to the work, and create optimizations that are far more powerful than we're able to do today by virtue of knowing, having a real-time picture of what's going on in that project. And by a real-time picture, I mean not only the, and I'll end with this, not only the product, but the process itself. So if I know what's going on at a high level of detail and high fidelity, then I can leverage that to plan better and have less waste. That's the idea. Whether it will be so, time will tell.
So Rafael, if you take into account the resources that are needed, yeah, is that going to be only a large design and construction firm tool, or you think this type of things in future can go down I would say, to a normal or lower scale production of companies and contractors?
That's a good question. Now, I noticed that the background has fallen here, and I guess that's one of the dangers of the digital world and the new way we're all working here. So with your permission, I'm going to stop the video for a second and fix that. Or perhaps we'll just...
yes, okay.
Perhaps we'll just continue. You can enjoy my pretty face in the image. Amir, so I'm going to ask you to repeat the question if you would.
Yes, I'm just saying about taking into account the resources that are needed for this type of process. So I'm thinking that it will be mainly directed, at least at the beginning, for large companies, large construction firms and big projects. Do you think that, which also was true, I think, with the BIM at the beginning, but do you think that taking into account these resources that we see here, the databases, the all automation and the artificial intelligence, this can also be a tool for, I will say, the majority of the small scale companies or small projects in future?
Yes, I think the answer is yes, because as I said, yes, it does require greater infrastructure and it does require more instrumentation and it does require information systems. But I think that what we see is, certainly with the startup companies who are already in the digital twin space and infrastructure, is that two things. One, they're able to leverage the cloud in ways that we weren't able to leverage in the beginning of the BIM world. So that software can be delivered without installation and so on. So that companies who are employing the technology are paying subscription costs, and that they can measure that against their better operations, improved operations, and so on. So they're not being required to make huge investments up front as they were in the past. And on the side of the startup companies, they're working off venture capital, and of course the risks are built in, and investors will consider what the risks are and decide whether they're worthwhile or not. Now, an advantage of such a business model is that smaller clients can benefit from that because the barriers to entry, if I'm a small construction company, or if I'm a small, I don't know, a road operator in a smaller country, or in a third world country indeed, the barrier to entry may be lower. And it may be that these things will be driven in the beginning by the much bigger projects where, because of the higher turnovers and the higher costs, the benefits are so much bigger, but the delivery model might be actually make it available to smaller companies as well. I think the barrier is more in behavioral change than in financial investment.
Okay. What about the overloading of data on site? I'm not talking about in the people who manage the system, but mainly on the end users. Do you expect an overloading on site or too many models or digital things? Because I know that today in some of the sites, they can handle this very good, but in others, it depends very much on the manpower. It takes a lot of time to make people more, I would say the system should be very friendly. People should train again and again in order to use it.
Yeah. I don't want to sound over-optimistic at all, and clearly there are challenges. But I think that the test of any software of any kind, and this in particular, is that it should actually make things simpler for people to operate than more complex to operate on site. So if I think, for example, of building automation systems where the computer system might be operating the air conditioning and the heating and cooling in a building, and if that system is linked up to the sensors throughout the building, and then if we add some AI to measure patterns of what's going on, and then use that learning to optimize the operation of the systems for cooling or heating, then actually that takes that task out of the hands of the human operator and creates the optimization through the AI. And we see that. There is a recent report from Arab, which reported a lot of cases of digital twins. And one of the examples they bring is companies using, IBM, I believe, using such a system to cool their data centers. And I suppose that will be true in construction as well. We need to have interfaces and intelligent systems that present to the users the relevant information in a succinct way without exposing all of the data that went into that from behind.
Rafael, we have here another question concerning the application of digital twins on existing structures. Is there, or two questions. First, what are the biggest challenges? And if there is any tool nowadays that can be used to update the digital model simultaneously with the decision making?
I guess that there are two parts to that question. If we want to update models simultaneously, with decision making, then those models will be BIM models which reflect our decisions about the future and how we want to build or maintain or operate some asset. If we want to update the models to reflect their current condition, that is the question of monitoring the real asset and putting it into the project status model. And that's very difficult to do in real time. The only ways that we can think about, or at least in the construction arena, are applications for construction safety. So for example, we can use camera systems with computer vision to identify perhaps a bulldozer or a grader, and identify workers who are working in the vicinity of that plant and that equipment. And if we identify them in real time and update in the project status model, then we can monitor their proximity. And if they're too close and it's dangerous, we can perhaps then send an alert to the workers in the field. And such systems already exist. They've been researched in academia for many years, and I think there are now applications that can be implemented. Actually monitoring the physical infrastructure, for example, knowing whether a column has been built, knowing whether a slab has been poured and so on. You can do that through visual means as well and through other means. There are, for example, I know that Lega Rock here in the UK are using a system, again, from a startup company, where they put humidity and temperature sensors into fresh concrete pours, and they're then able to update the digital twin in real time about the condition of that concrete. So there are solutions that exist for doing that. To the best of my knowledge, most of them nowadays are single track. By that I mean you have a single set of sensors creating a single set of result information. I'm not aware of any really good solutions where you can say, let's take the information in real time from the sensors in the concrete, from the cameras, from perhaps some other monitoring, from perhaps reporting of workers, synthesize all that together through complex event processing and come up with a succinct conclusion about what was done. Was it good? Was it bad? Was it in time? Was it overtime? Was it costly? Was it, in budget or not? So there are technologies for doing that. There is still, I think, a long way to go in terms of merging the information from them to make sense of it.
Okay, I have another question here about, actually I can translate it to, what do you think will be the change that will need to be done in the way that engineers and architects are going to study in university? Do you think that actually some of new, I would say, new programs should be established, and people should get out from university probably with a different knowledge than they are going out today? They should know probably more programming. They should know probably more about system management. How do you see that?
As you know, Amir, we have a wonderful saying at home in Israel, which is that the person who makes the sandals goes barefoot. And I fear that I am in that position, because as an educator in university, I am very keenly aware that we need to change a lot of the ways that we educate engineers, architects, managers, and others. And yet we find that that's very difficult to do. And that as difficult it is to change the construction industry, so I fear it is difficult to change the education industry as far as the university is concerned. And I see Jose smiling, and I guess maybe you will agree. It's been a challenge to introduce BIM education within civil engineering, not so much in architecture, that's even better at it. And it is true that the discipline of civil engineering is becoming perhaps more dependent on data science, on systems engineering, and other aspects than it has been in the past. And that may be true for other branches of engineering too. Perhaps no different. So perhaps engineering education as a whole needs to undergo some certain transformations, and I guess it will, but it may be that it lags behind the industry rather than leading the industry, sadly.
So actually the engineer of the future is not the engineer of today, probably.
I think that's been true for many years.
Yeah, but it takes a long time until the process is even moving. That's what I see.
Well, that's true.
Rafael, also picking up the process, there is here a question: if digital twins model the product, or both the product and the process, how should we model the process?
Okay. Okay, so modeling the product is nowadays fairly straightforward in using, we have a lot of different options for BIM software in which we create objects in the software that represent real-world objects, beams, columns, slabs, and so on. And indeed, in fact, we already do that for the processes as well. So the simplest thing I can say is even a software like Primavera Project Planner or Vico, all these software that model the processes and allow you to do planning, they have objects, they have activities, they have relationships between activities, they have properties of those objects like the durations or the resources themselves are modeled as objects. So in fact, we do already model the processes. Indeed, when we create what we call 4D BIM or 4D CAD, we are combining the process models with the product models to create a more comprehensive view of models in 4 dimensions with time. So software for doing that we do already have. Now the question is, do we have that for the project status model? So a project status model might be a federated model. It may have point clouds, it may have images, it may have BIM models representing the current state of that project, which is, although it's a BIM software, it's still a PSM as opposed to a BIM model. But if we then create object-oriented schema for modeling the processes, we can model those too. Interestingly, the IFC, or the Industry Foundation Classes schema, which we use as an open BIM solution, it does have within it the object definitions within the schema and the hierarchy to model all the activities, the processes, the resources, and so forth. So indeed, if the software can do it, the standards, the data standards already exist. So I think that that's actually a part of technology that is the easy side. We already have a lot of that.
Okay, I have a question maybe connected to the presentation that was made by Rade last week. I don't know if you saw it, or about the bridge, or say the problem that we have, the bridge collapse recently. And I think the last sentence in the conclusions was just saying, BIM can prove to be quite useful for this. And the word this was related to information that the BIMS and owners should keep and maintain, in a useful manner. And how do you see this type of system? You were talking about site safety, but we are talking about, I would say, a network safety, or something that actually can be very helpful to this type of process. How do you see this type of systems getting into this network management in more than one structure, I would say?
Perhaps the answer sits in this idea of systems of systems and systems of systems of systems, because the responsibility and the ownership for information at each different level is not uniform, it's diverse, and it's spread across many different authorities and organizations. So one organization might be responsible for road bridges, another one might be for railway bridges, and somebody else for the railway network, and somebody else for the trains running on that network. And of course, individual people are responsible for their motor vehicle traveling on the highway bridge and so forth. So the question then becomes, can we create links between those different networks that share the information? If I imagine for a moment a bridge management system, which I know, Amir, you developed both in Israel, and I know that the Cost Action developed or is developing standards for bridge management systems internationally. And those bridge management systems certainly can use digital twin representations, visualizations, as, if you like, the platform on which to hang all of the other information that you have about whatever bridge or asset. And the companies like LockLab and Dynamic Infrastructure I mentioned before, they really can do that already, because they can create the visualizations fairly quickly, and then it creates a very simple access for most users to access the more complex information. And once that information accumulates, you can then expose it to other systems. Now, as a simple example, you might say, what if I expose that to Google or to Waze? So now you might have the status of a bridge and its load carrying capacity, or works to renovate that bridge or to maintain it, or perhaps some load carrying limits or temporary limitations on load carrying capacity fed into somebody's travel planning software, so that then the whole network of the people planning a trip can know that a particular bridge is not available to them at that particular time. So I think that some of those systems, in terms of the bridge management system, as I understand, and development, they'll become much more sophisticated. The route planning systems already exist, and they're already commercial and in the hands of every user. And then how do we create the links between them? Well, I think those are also not that difficult as far as software engineering is concerned. So when we distribute the effort, then I think it becomes much simpler to link the systems correctly.
And from what I've seen until now, I think that the visualization is the part that is already there, while I would say the semantic enrichment that we are actually looking for is in most cases not there. It will take time, and it's much more complex maybe to do it. Because I saw that the world that people are coming, or the companies that are coming from I would say the high-tech world, they have a lot of investment in visualization of things, and they are not familiar with the specific needs of that system or the other system in the civil engineering, which might be a problem.
I think that like with anything, most of us are risk averse, and so startup companies and those developing these systems, they try to apply the things they have most confidence with, and they generally try to generate what they call their minimum viable product. So they'll begin by creating something you can use, yes, even if it's rudimentary. And then over time, they will improve that and figure out your needs and be able to respond, but they need to create their revenue stream right from the beginning. So yes, there's a long way to go, but once you begin, you have the platforms, you have the ability. Whether they will ever, whether we in research will ever be able to solve the real core problems of either of the complex event processing or of the semantic enrichment remains to be seen. But when we do, I believe that some of the platforms that can use business platforms will already be in place.
Mm-hmm. Rafael, in line with what was mentioned by Amir, we in the cost action 1406, we identified that for existing infrastructures, the need is in semantic enrichment, but also with some of the operators that were involved during this action now in EuroStruct. We try to convince them to use BIM and digital twins for as an advantage for the operation of their infrastructure. But still they have several concerns and several doubts concerning, for instance, as an example, how they could get information about the hidden part of the infrastructure, or what investment could they make in order to obtain BIM models of existing infrastructures. In your opinion, and within a cost-benefit analysis, what would be your recommendation for these owners, and that some of them are here with us today, and your experience also maybe from other countries that are already still starting to invest on digital twins and BIM? What is your recommendation for them?
I guess the first thing, of course, is to expand your learning and get as much information as you can about all these things. And a good place to begin is the Center for Digital Built Britain here at Cambridge, who have a digital twin task group and who really are, I think, exploring, together with many of the local UK infrastructure operators, exploring what the values are and how it can be done and what can be done. I think that there are many companies here in the UK and government bodies and government agencies who are slightly ahead of the curve as a result of their adoption of BIM following the UK government BIM mandate, which came into force 4 years ago, just over 4 years and a month ago. So they've been pushed ahead. And I know that through our research, we found that some of them have discovered that actually the way they can get most value from BIM in their projects is to extract the information from those projects managed using BIM and then absorb it into their system information models and begin to build up their information base about their own assets. So one way is to learn from those who are ahead. The second thing I would strongly recommend is explore what the different startup companies are doing. I mentioned two of them, and I'm sure there are many more if you look online for digital twin construction or digital twin infrastructure assets and so on. There are a number of startup companies around the world, and they offer different services, but I think that is what is probably the easiest way for an organization to start taking steps into getting the value from digital twins.
We have also here another question, Rafael, concerning how digital twin can be used for the cultural heritage.
For historical buildings, is that?
Yeah.
Yeah. So, as we've seen in many places in the world, and it appears in many research papers, the idea of creating digital twins of historical buildings is an excellent way to maintain them when they are subject to destruction in the real world. The most recent example, of course, is Notre Dame Cathedral, but various assets in Syria, in Iraq and Iran are similarly things that have come under very heavy damage, and in many cases, either through laser scanning or other kinds of modeling, they've been preserved. But I think it goes beyond that. A colleague who will begin a postdoc at the Technion very soon, Dr. Silvana Bruno from the University of Bari, has completed a PhD where she examined how to use BIM for compiling digital twins of old buildings, of heritage assets. And the main use of them was to determine structural failures or performance failures, things like cracks or degradation in mold and dirt and other things in those buildings, and an attempt to figure out how to use the models to then take the right decisions about how to maintain them, how to renovate those buildings, and how to restore them for least cost, which is not obvious unless you have a full information picture of what that building is all about. Much in the same way, you might want to prioritize which bridge you fix first in a network of bridges, or where in the bridge you treat first, if you have limited resources. So I think there's little doubt that digital twins, both as a repository for cultural information, but also as a repository for maintenance planning and optimization, can be very valuable. I don't have any particular experience or knowledge about that, and so the research literature is full of papers. I would strongly recommend reading up about what has been done.
I have a question, another question. If you take the process that you described with all the, I would say, artificial intelligence, the machine learning, the visualization, can you point out where is the weak point of this system? It means what is the balance between the things? Where are we strong now today, and where we are more weak? I would say needs more time to develop it.
Mm. Amir, that's a good question. I think that while we have the initial tools for acquiring the information from site, some things like detecting cracks, like detecting spawning, detecting problems in real buildings, in real bridges and so on, is still very difficult. And part of the reason for that is that we require still today, even with machine vision, we require very high resolution images, which are not trivial to connect. They require cameras to be really up close and stable. There are developing solutions with all sorts of autonomous vehicles of one kind or another, but they're fairly slow and complex, and you cannot operate them in all environments. Wherever there's traffic, we can't use drones, and the vast majority of bridges are over highways. There is still a lot of work to be done in acquiring detailed information. The second thing is that we still have problems, as I said before, in interpreting what was done in the process. Workers, I may, for example, know that workers were located in a room for some time. Maybe I've monitored them using Bluetooth low energy, which is something we've tried in the lab quite a bit. And there are startups operating in that area as well, such as Genda. But if I know they were there, I don't necessarily know what they were doing. And I would need to merge that with perhaps some images of what was done on the site to be able to figure out if they'd built a wall or not built a wall, or they'd done plastering or not done plastering, whether they had used the right materials or not, whether that wall was built in the right place or not. So there's a lot of process information which I need to fill in, which nowadays I think we're not there yet. And again, there are startup companies like Reconstruct who are trying to do it, and others, but we need to be able to merge the information. So problem number 2 is the complex event processing. And then I think perhaps the third problem is, I don't think yet we have good case studies or examples of real translations of the benefits at system levels, either of a whole construction project or of managing a whole bridge or highway or railway or other systems, or buildings, or managing operating buildings. And so I guess there's still quite a bit of business research to be done there to create and perhaps define the correct processes to be used. What makes sense, what doesn't make sense, what has value and what doesn't. And maybe, and we haven't touched on this at all, but there are, of course, also ethical questions and privacy questions and ownership questions. So there are that, I guess, social and business envelope that also needs to be studied more to determine what are the right ways to do things, not just leave it to business to develop and for those aspects to catch up later.
Rafael, I'm going to place from my side the 2 last questions, and then I will ask Amir to put the last question from his side. So concerning my 2 last questions, and although we have here many questions from other participants, but I'm going to pick one from one of our colleagues from Cost Action 1406, Yanis Yanidis from Greece, about the scalability of the digital twins. What will be the realistic scale when we have, or we take into account the system of systems? This is the first question. And the second one is how or what can be made in terms of contractual models in order to encourage the use of digital twins by all stakeholders?
Scalability. Honestly, I don't think I'm in a good position to answer that question. A simple answer might be that as soon as we move things into the cloud, it appears that we have the computing capacity for both computing and storage of information, and it appears that that capacity is growing all the time. I suspect that the amount of information that we need will be very, very large once we get streams of monitoring data. However, it seems that our capacity for images and photographs of cats and videos of kids doing things on Facebook seems to be enormous. So perhaps that won't be such a technological challenge. I think the issue there will be to decide what to store and what to throw away. And once we get the interpretation of the data streams right, and we get the event processing right, then we'll be able to throw away a lot of the live data streams, not store them at all, but store the intelligent information that we interpret from them. That should make it easier. The second answer is that as long as things are distributed, then it makes it easier and the scalability is easier. So we don't imagine, I hope we don't imagine an individual government trying to create some enormous national digital twin of everything in that country and maintain it and so on. No, I think we're talking about very distributed systems that need to be coordinated through standards and through operating procedures, but they're never contained in one particular place or monolithic in any way. The second part of the question had to do with contracts, and there I guess that right now, obviously one key way is for owners, for builders, or especially government organizations who are major consumers of construction industry, for them to stipulate the use of BIM in design and in construction, because then the result is that we slowly grow the amount of digital information that we have for our assets. Now, I don't want to imply that that information can be ported one-to-one into digital twins. No, that requires some massaging, it requires detailing, it requires change. And it definitely requires the owner, the client, to be savvy and to know what they need. So ISO 19650 is the new BIM standard, and I think it lays out the process reasonably well, in that it places huge emphasis on the client defining what they want. And many clients begin by doing that with consultants, and so it doesn't really work. But over time, as they become more sophisticated in using the information systems they own, they do become more sophisticated in stipulating to their suppliers what they want. When we provide a digital asset along with our physical asset at the end of a construction project or of a maintenance project or a renovation project, then if that digital asset is correctly defined, it should be able to plug into my operating system, asset operating systems. And I think that companies adopting ISO 19650, taking seriously the idea that they are the clients and they have the power to stipulate through their contracts what information they want and in what format and in what syntax, that's probably the first place to begin. Yeah.
Well, I think from my side, I think you already answered the last question that I already wanted to ask you about how it is going to be, I would say, integrated into quality control plan management. But I think it's quite clear from the previous question that we still have a way to go, but it can be used very, very efficiently if we have the resources. For me, the main concern is actually the resources, the human resources that we need for that. In order to our clients, you know, the owners, that will actually be able to pay for these people to manage these systems. It's a long step forward, you know, even for normal BMS system, some owners still have a way to go, you know, so that's one of my concerns, although that sometimes those bodies are investing money in information system. That means that they know how to invest if you can prove them some benefits. Okay, but we as a civil engineers still did not connect the benefits, the direct benefits or the future benefits from connecting this type of system together. And I think this is a challenge for us as a whole civil engineering world, not as electronics or computer science. That's one of the things that I see. I don't know how you see it, but.
Yeah, I agree. And perhaps just as an anecdote to end with, it's enough to go and look at the enrollment of student engineers, in which departments they're enrolling. And I think it's fairly true in many countries in the world. The enrollment in information engineering, computer science, electrical engineering is growing, and the enrollment in the more traditional mechanical, civil, and other engineering is declining. And that's the direction our world appears to be taking.
So now it's my part to finalize. Once more, I would like to first acknowledge Rafael for being with us this moment and this period. It was very nice and very fruitful for all participants from all parts of the world. So I wish to all a good day or a good night, depending from where you are. I also like to acknowledge Amir for the very good moderation that he took with us. The talk will be, it is recorded and will be provided, so everybody could anytime go to the YouTube channel, LinkedIn or Facebook of EuroStruct and can see again the presentation and the conversation from this talk. I would also like to acknowledge our associate partners, FIB, and concerning FIB, I'd like to say that for those that do not know or that know, the next conference from FIB in Shanghai will be held from 22 to 24 of November of 2020. So you can go to the FIB website and submit there your abstract and the paper and so on. And I also like to acknowledge Umingo and Isis for providing the Zoom platform alive, and to Boutique for all the support in the design and promotion of these talks. And finally, I'd like to give you also some information concerning our next activities. So 27th of May at 2 p.m. Central European Summertime, we're gonna have a talk with Michael Faber. That will be very interesting about the sustainability and the technology consensus. That is something that is working since a while until now, and very in line with what we are facing nowadays. The training course from EuroStruct that is going to be a hybrid course part for those that could attend it to be in Dublin in Ireland, and those that cannot attend, we are going to do it with digitalization online from 2 to 4 of September this year. And I also like to inform that soon you're going to have information about EuroStruct 2021 in Padua, Italy, from 29 to 31 of August 2021, and hope to see you all there, and also some of your students and colleagues and so on. That will be very nice. So once again, I would like to acknowledge all of you, and especially Rafael and Amir to be with us today, and see you next week. Thank you very much.
Thank you very much, Jose.
Thank you, Jose. Bye-bye.
Bye-bye.